righty, let me get Joe past here. Oh. All right, so a couple of things first here. Welcome to another session, live, ESAB University for Weld-On, April, National Welding Month. We have an esteemed guest here today. Mr. Garrett Vickery is our NDT instructor here at Cali College. We've been on quarantine, but we've been having to do some recruiting, and we're kind of running around doing all kinds of stuff, huh?
Everything distance.
Oh man, I don't know about you, but I feel like my workload just increased by 4. Mm-hmm. And in the meantime, you know, we're gutting the shop here. We're trying to paint back here in the corner, dress it up for you a little bit. Well, your area is always nice, you know. Mm-hmm. You got a nice little project done the other day, didn't you?
Oh yeah, we knocked out some walls, opened up some space, really made the workflow increase. But then now students aren't in to utilize that space. You know?
Right.
But
we'll have to do some. We'll have to get us a build going on your back shipping dock there and incorporate a smoker or a grill or something, huh? You got a nice area for it down there. So what have you been doing for, distance learning? You've traditionally had things online anyway, but did you do anything different?
Yes, so with Blackboard, that's our online learning system for all the students. We post weekly quizzes, worksheets. I'll make demonstrational videos. I'll strap a camera on my chest.
No.
A little GoPro with a chest harness. Go into the lab and do some fun things, and I'll mess up on purpose by design. I'll do something not to code.
I don't do it by purpose. I do it anyway.
I will, and then I'll post a follow-up quiz about that video that I posted, asking them what did I do wrong, cite where it says that that's wrong, and then tell me how to correct that. You know,
cool.
Trying to keep their stimulus, trying to keep them stimulated and engaged without physically being able to do it.
Gotcha. So as far as hands-on or anything, you really can't do anything in that respect. Equipment, nobody's going to check themselves out a ultrasound machine or any of that kind of stuff.
I'm not willing to let that go.
Well, as you know, I created a bunch of coupon dummy little hand-eye exercise thing.
Yeah.
It seemed to work out pretty well. Those that are using it have come back in and they have said that made a difference. Camera guy, that make a difference?
Oh yeah.
I mean, kind of comfort level type thing. So
it's some muscle memory, motor control, right? We have a little less of that.
Right.
That requires us to have what we need, viewing or trying to view a radiograph or to set up an ultrasonic machine. Like, you actually have to have the machine to do it, but you guys can just practice that muscle memory.
Right. I always enjoyed doing the radiograph, the interpretation thing, because man, some of those they just fall into a couple different categories. So as a demonstration today, and I've trying to play off the eminent and distinguished colleague, Mr. Ian Johnson. Some of the stuff that he presented last week, one of them had to do with preheat and post-heat cooling and welding on some cast steels, cast iron type thing. But I wanted to go ahead and show you real quick, in case you were interested, the coupons that we were beveling, or coupons. Mm-hmm. A lot of people have commented on, what are you using to bevel with? What is that? And I'm thinking, how do you not know? But apparently they don't. I think I featured Dez in a little short clip. Camera guy's son there, Dez, came in to visit, and I asked him, I said, are you ready for this? Is this a go? And so we've duplicated it over here on the positioner. It's a turntable, and we've got the Cutmaster 60i. There's a new little plasma cutter. This thing gets after it pretty well. Does everybody hear me okay? We good today on audio? Good to go, huh? You can hear me this time? It's not like I'm speaking through the turlet bowl or something there. Okay. You're going to need a hood. I'd say grab that old-time rascal over there. I'm going to wear my Sentinel. Now, by the way, folks, I do believe that, I hope that lens doesn't flash you.
That looks good.
Man, I lit up at 275 the other day doing a couple of field passes, and that hood and I were not on the same, huh?
Everybody's saying good sound.
That thing I was on 2 different zip codes or something. You don't adjust it. I mean, I've got it set, but I'm saying it wasn't activating, so I think I bought some dud batteries or something. I don't know, but anyway, it's a UV process over here. We're going to do a little cutting. So let's get to it. Oh, before I get to that, I read a deal here this morning, and it was like, who are you inspired by? Who are you inspired by in the industry?
Yeah.
Anybody?
I'm inspired by my mentor, man.
Well, who's your mentor?
Joe Klassen.
Oh, yeah. Joe.
Uh-huh.
Joe. We got to mention Joe.
Well, you don't get to choose who your mentor is, man.
Well, I guess not. Sorry you got stuck with that. I mean, yeah, he's a solid character.
Definitely.
I got pictures of him wearing them big old goofy glasses there.
Well, how do you get from point A to point B? You take a road, and somebody paved that road.
That's right. I'll tell you what. He's a really, really good teacher. He doesn't quite bounce off the walls like you do, but he is inspirational in his methods and his in-depth. So I'm reading this deal this morning, and it just dawned on me. You know, I'm inspired by a lot of folks in the welding industry. Apparently, a few of them look up to me for some reason, and but one of them, I have to give him a shout out. Sam Hackman is a ESAB elite crew member, and he's got that youth and.
Fortitude.
What? I just happened to be wearing his shirt today. Sam, thanks a lot. I'm sweating it out in your shirt, man. This thing is comfortable. But really, I mean, the guy does some cool work. He is, he's a fabricator, and right now he's doing a shutdown back in Pennsylvania. And I'm thinking back in my days of pipe welding and being out in the field and stuff, and I'm going, God, I wish I was there again. I can't turn back the clock though. I'm getting old. All right, let me grab a pair of gloves. Be right back. Oh, we'll wear these right here, be good enough.
We're going over to
We are going over there. I probably should. I hate to, but I probably should be covering up here. Let me get a welding coat on. You be all right there.
Stand out the way. Get out of the line of fire, right? In that way. You're asking where Garrett's safety glasses are at. Oh, baby. Thanks, man.
Yeah, I'm about tired of you coming up into my shop not wearing safety glasses.
Well, I was going to put the hood down.
It doesn't work in here. Then if you're wondering why I'm grimacing when I'm putting on this jacket, is because my shoulder hurts. It really does. Yeah. Seriously.
That's not your golf swing arm, is it?
I can't even swing a golf club right now. I'd probably wet my pants. It hurts so bad. Seriously. It's bad. I'll tell you what. If I tried to swing a golf club right now, I'd look like that night that you threw the club on the par 3.
Par 3, hole 5?
I wish I'd have videotaped that. God, that was funny.
I'm glad there
Wow, that was funny.
Like a plausible deniability.
Woo, that was good stuff there, Javier. Oh, good stuff. All right. Yeah, cut master. And I am going to modify. Come on up in here. I am going to modify this somewhat. I just got this torch, the mechanized torch out, and you probably don't want to be standing there. You can, it's all about amperage and speed. I'm cutting at 50 amps right now, and I just want to turn this bevel. And we only bevel one end. We make the weld, take it up to you guys. You do your x-ray, your visual, your x-ray, scrutinize it, bring it back, and we just cut the weld out. So in any event, and you're asking, why am I just sitting here with no gauge, no whatever? Trust me, I've seen 37 degrees before in my life, and I know what it is. And we're cutting all these different diameters, and so it's all about the speed here, the amperage and the speed. And we'll do a little pierce here, and then we'll blow and go. You ready? like a 40,000 degree needle, huh?
It looks like a little needle, like a little, like a thread, like a sewing thread needle, just cutting right through there. Okay, okay. That is clean.
It wouldn't.
And all you gotta do is deburr on the inside a little bit, and then put a face on it.
That's it.
That's beautiful, man.
Clean them up with a file. I mean, again, we try to save material. Material is expensive. We just clean these up inside and out.
Well, in time too, in a little class period, you know, you gotta utilize as much time as you can.
Yeah, we got to keep the flow going. So, clean those up. We'll do a stick, MIG, TIG, saw. Oh God. Oh. Huh. It's basically the same setup for everything as far as the cleanup goes, and I'll demonstrate that here in a little bit. I've got a bunch of folks hounding me about doing root passes on stick and stuff, so I'm gonna do one fit, uphill, downhill type thing. So, all right. I don't know if it'll work for you, but one of the viewers today, those that are commenting, that are in attendance today, I believe they're going to win the new Savage hood.
Oh.
You can be a Savage. I don't have one. I kind of like to get some hood time in one. They look really, really sharp. Anyway, you have a class to teach.
You know, yeah, I got 10 minutes till.
I know, and I'm not necessarily running you off, but I'm going to run you off. You know.
Okay,
No, I'm joking. Make sure you leave your safety glasses behind.
I'll give them back to
Ashley. What do you have, like 27 pairs now from coming down here and visiting?
Well, I keep one in the drawer in there for when I sneak in here. I can just swipe one out the drawer, but I came in the back way this time and just plumb got excited, man.
Man, oh man. All right. Well,
hey, thanks for having me, guys.
You bet.
Hope you get to have a good stream.
We need to, so let's quickly talk about Cali programs. Obviously, we do not have a program down here that is gender specific. Women do extremely well in these programs in career and tech ed. I've had a number of women welders come through. You've had quite a few NDT people. I know of a young lady who's extremely successful, who graduated machine tool over here before Rick, though, you know. But she's down the Dallas-Fort Worth area programming for aircraft parts. That poor girl knocks down about $150K a year. So, automotive the same way. We just don't have a program that's gender specific.
No, we had a lady immigrate from Mexico, get her citizenship during taking classes, and then get a job at Spirit Aerosystems, building the Boeing jets there, doing automated ultrasonics and eddy current testing. Man, she's
nice,
sharp.
Nice.
Yeah.
And we got Buddy's got the ag programs up and running in Wellington. We've got the milling program here for our local constituents. Yep. Milling is an art. That's an art form. These two mills that we have in town are just completely different. I don't know if you knew that or not.
No,
ADM East and ADM West. West right over here.
That's the one I've been to.
This one over here on the east part of the town, real critical in grinding up for flour and stuff like that. And I mean, everything comes into play. Humidity, moisture, I mean, everything. It's unreal. And these over here, I think they just kind of rough grind or something. But it's
one's for cattle, maybe another one's for.
Oh, I don't know. It's an interesting science, though. So anyway, we've got things going on for Cali College, that's for sure. I don't know what other colleges are doing since I've heard a lot of people just completely shut down, phased out, cannot enter type things still. And we are bringing people in 6 at a time and maintaining distance and whatnot.
Yeah.
Hey, be a sport and grab my stool over there, will you, about next to my toolbox? And since I built that thing for you the other day, you ought to find me some casters. I need some casters on here, some high-speed wheels.
All right, boys. Thanks for having me, everybody. Have a good stream, Bob.
Have a good class there, young man. We'll check you out later. Now, we're getting into preheat, post-heat, that kind of stuff. I talked to Ian Johnson this morning, the infamous Ian Johnson. We were talking about torches and stuff, and I told him I have got an sundry here, and I wanted to go through them real quick. So I guess he didn't believe me, or maybe he did believe me. All right, get this out of the way before I stab myself. I told him I had a little baby jeweler's torch, and I also told him that you pluck one of your human hairs and put it down that orifice right there. If I'm not mistaken, that has a diamond insert in here. There's a little bitty tiny thing, and it comes with about 5 different tips on here. And I fired it up one night, and I about blew myself up because I've got a leaking acetylene valve right here, and I don't know how to go about fixing it. I tried to back it off, and I couldn't get it out. But I am going to study this thing because I'm dying to get it out and do some stuff. And then one of our local welding supply, Mr. Zach Peel, turned me on to this little tiny rosebud. I saw this thing sitting down there, and I couldn't believe it. I've never seen one this small. I like rosebuds. I like to preheat things, and I like to use the rosebud to keep it warm after I weld it, and I want it to cool slow. So I found this little guy down there, and I ended up silver soldering this part on here because I wanted to get them set, and I wanted my hoses to be away from or separate in here, but I found that to be kind of cool. And then we've got this guy here, which is pretty common. The super range size, the Victor 100 FC. I've been operating all kinds of equipment over my years, Smith, Harris, and all that, but I'm just kind of a Victor guy. I've always been a Victor guy. Purchased a set in 1985, I believe it was. Been in the shop one time, and I think that was a diaphragm that collapsed on the oxygen side, but in any event, good equipment. I've actually attended a sales conference in Denton, Texas years ago. Met some fine folks down there and learned a lot. I learned a lot of cool stuff. At FabTech this year, the throne that was made out of all the torches and stuff, everybody used it as a photo op, obviously, went around, and some people had that separate torch that was standing up next to it. Some of you will remember that. I had that in my lap a long time ago. I actually saw the video of when that thing was first fired up. The guy that was operating it was getting ready to cut a bridge ram, which is what that torch was designed for. He's getting ready to cut this bridge ram that's probably 32 to 36 inches in diameter. It's a massive chunk of steel. He's sitting on a 5-gallon bucket, and when he pulled the trigger to make the cut, it knocked him off the bucket backwards or whatever. He didn't know how much power is behind it, but it's an amazing torch, and it's for scrap cutting. It's a hog. And then we've got our regular journeyman size, the heating. We've got our regular stuff here. This guy gets after it and throws a big flame out. I just never get up above 10 psi on acetylene pressure. I'll run this guy up about 10, and I turn it on in stages, and I'll light it, quickly turn some acetylene on to get this flame active, and then I'll start gradually adding some oxygen, and I turn it up quite a ways. Some of you that have operated a big old rosebud or heating tip like this, you get that backfire, that pop. I'm telling you, it's a little unnerving. So you got a lot of pressure, you got a lot of heat coming out of here. I asked a trick question one time, kind of sort of trick question. I've got this size torch, I'm running oxygen and acetylene, and we've got this guy here, cute little rascal. What's the temperature of the flame coming out of the end of these nozzles, given the fact that we're running oxygen and acetylene? Camera guy, shout out some answers as they come across there. Anybody want to take a guess? What's the temperature of the flame as it exits the tip? And speaking of which, camera guy's got a little repair to do. moving right into a practical application, I'm going to fire this guy up and do just a bit of silver soldering. I like silver soldering. I like oxygen acetylene, welding, brazing. I've been doing a lot of TIG silicon bronze.
I said
4800,000. What number is that? Huh? 4800? That's too cold. Come on, man.
Robert Dawson said 1800 Fahrenheit.
Fahrenheit, that's too cold. And I do want the answer in Fahrenheit, please, so I don't have to do a calculation. That's a little too cold there, man.
3,000.
How much?
3,000.
Nope.
2,200. John Mensch said about.
Man, you know, you guys got to go to school. You got to look some stuff up there. Come on. How much?
5,800.
Who said 5,800?
John Mensch.
Who?
John Mensch.
Come on, John. John Mensch with ESAB.
Ty Sumich again said 7,800 to.
Well, I like the 5,800 number. That's good. 58 to, some of them will argue they'll go up to like, what do we call that there? 6,300. I like 58. For a neutral flame, I like about 58. Hey, where's your part, man? Did I get it? Oh, yeah. What do you got here? Thin wall, scary tubing, junk. Sorry, I'm not picking on you. So, I'm sure some of you have been exposed to these guys here. If you live in the Badlands here where it's windy and you've had an awning or one of those pop-up tents or something, you can ask me to repair it, and I'll probably say no because it's aluminum and it failed. This one is carbon steel, but it worked back and forth and it broke itself right in here. So this morning we went in and prepped this. We actually built a copper tube and shoved it up inside there. Grab a copper tube from underneath the table over there, right there below you. Yeah. We cleaned up a copper tube, and it just so happens that is the right size to go inside there, and we drilled a hole. But all we're doing is strengthening this on the back. So now we need to kind of bond the joint. I could go in with gas metal arc welding. I could spot MIG that. I would probably turn my voltage to about 16.8, 16.5, something like that. Turn my wire feed speed down real low. But I want to do some silver soldering. I'm kind of curious to see if this is going to go. Let me go grab a piece real quick. By definition, we have oxyacetylene welding, which is obviously melting the material. We have brazing, and we have soldering. So the question is, define each, or what is the temperature range of each? What is the temperature range of each of those? Oxyacetylene welding, we're obviously melting the material. Brazing is defined as what? I may get...
You want me to zoom in on that?
Huh?
You want me to zoom in on that?
Yeah, you can come right over here. Come on up in here. You can get right down over the top of it if you want. Show the viewers what kind of mess I'm going to make here. This will flow wherever the flux is, so I want to get a generous amount around this joint. I can always clean this part up later on. If I get sloppy and get material on the inside and into the hole that we've already drilled, I can always go back and file that out or put a burr to it or re-drill it. My choice. Camera guy's choice. And I'll just do the top part of it for now. I will go ahead and flux that down there. I've been here at the college for 20 plus years. And when I got here in my first year, I went and bought a tube of silver solder. It is about a 1/2 inch square, about 18 inches long. It cost $96, $98. I use it all the time. I make a lot of repairs on machine parts, dissimilars, brass, stainless. I'm using it all the time. I still have over half of it. I just thought you might be amazed by that. And I'm going to go ahead and use this stuff here. This is a different alloy. So what happens here is as I heat this up, the flux activates, goes dry, and then it gets wet again. That's about the time that we want to add some silver solder. I thought you turned my cylinders on. Oh, you did. I have a small tip in here, and that's all I really need. Again, this is paper thin tubing, and I'm scared of it, so we'll get this flame down here real tiny. All right, you want to get right up in here?
Yeah, listen, man.
So here we're already. We dried out, and now we're going to come back wet, and we're getting to that temperature. From experience, I can tell you, doing a lot of repairs like this, whoever invented powder coating wasn't thinking, open that jar for me, please. Whoever invented powder coating wasn't thinking of us guys that are going to do repairs and stuff. That is the most, you got to do some major cleaning. Powder coating, MIG welding, or any kind of repair on MIG, TIG, just don't get along at all. I don't want to put anything in there. I'm confident. Our repair is made. All right. You know what's going to happen here is I'm going to do some other demonstrations, and I'm going to forget that that plate is hot, and I'll put my forearm down on it there. You guys will laugh at me. It's not funny. Did you zoom in here, sir?
Yeah, I did.
Right over here?
Yeah.
So, well, I mean, you can get right over here on top of it. And what we need to look at is like right here. There we
go.
So it kind of flowed in nicely. And then we'll go back and I think we got to do some work on the pen, but at least we saved this part. We got a little blacksmithing work to do down here and bend this thing back. Well, hey, we saved it. Don't know what it is, but I don't think you can find it anymore, huh?
I don't think so either.
All right, well, there you go. How much do I charge you for that? Oh, it's a push. You're operating the camera for me today, huh? All right. What else? I'm going to set this aside. So there's an example of using the torch, the flame. By the way, did anybody answer their brazing type deal? John Minch, what did he win anyway? 5,800 degrees, he said. John, you need to call me sometime. There's what you need to do. You need to catch up there, old bud. I run quick disconnects on everything in here. It kind of keeps the weekend warriors out of here. So for safety, I just like to disconnect stuff, put my torches away of an evening. Again, that was a triple aught tip. Real thin tubing, wouldn't want to blow it up. So what else are we going to do? Oh, we got a bucket build.
What are the strength difference from solder, braze, and weld?
What are the what?
Strength difference from...
You know what? People can hear me on the audio. I can't hear you. You got to speak.
Strength differences in solder, braze, and weld.
That's a really good question. Here's what I'm amazed by when I said that I had that 1/2-inch tube of silver solder. I'm reading the technical specs, which is I'm like one of the ones just ate up with technical specs. I want to know what's in it. I want to know I want to know everything about it, physical capabilities and stuff. Believe it or not, silver solder, 70,000 pounds tensile strength. Come on. Are you serious with that? You know, we're not even melting the parent metal, but yet we're bonding it, and it's 70,000 pounds tensile strength. To me, that's amazing. Call me weird, but I'll make a lot of repairs with it. And I think it's cool stuff too. What'd you do with the 2-inch pipe circles, sir? The ones that you're supposed to deburr, buff? Huh? 4?
Yeah,
But how many you got here? Enough? We'll see.
you want me to finish these off?
Nah, there's a couple more over here that I cleaned earlier. I do need something else though. Why don't you hand me that bucket over here? Hand me my rod bucket. Yeah. All right. Got some cool tools in here. Where's the banana hanger thing? So, some of you are familiar with my time with Weld.com last May. I went down to Florida and we did this parody video on the bucket organizer thing. And one of the comments, which I appreciate, was, well, I just want to build it out of common things, common tools, or common stuff, I should say. And I did. I mean, that was the whole concept behind it. The first one, I came back from Houston from judging a contest down there with South Coast and Weld Tube. And I was inspired by something that I saw, and I rolled a piece of 5/32 filler wire, and I tacked some stuff onto it, and that's what I'm trying to hold to, is building it out of common items that you would have. You don't have to have a CNC plasma cutter. Surely, I mean, that would be great, but hey, we're out in the field and we want to build something to organize our rod. And I cut pipe slivers and did mine the first go around, and then it dawned on me that well, you can make and put this stuff together, but your rods are still going to swarm all over the place and stick out the sides of your bucket, and that's what I don't want. Huh?
Someone said the microphone sounds muffled.
Microphone is muffled. God, not again. Microphone is muffled. Well, what do we do? We got brand new batteries in. We got all this cool stuff going our way. Is that better? I mean,
Let's see if
I don't get it.
Sounds fun. Everybody's saying it sounds fun.
Oh, just that one person?
Yeah.
Apparently that one person doesn't want to win the Savage 40.
Yeah. Everybody's saying it sounds good.
Okay. Appreciate you folks. Anyway, what I kind of came up with, it kind of dawned on me. I challenged my students. I said, and you guys can relate to this. It's like you be driving down the street and all of a sudden a good idea comes to you and you think, oh, I'll remember that, you know, and you pull in the driveway and you got 4 texts later, which you shouldn't be texting while you're driving, but 2 phone calls and you forget what you were supposed to remember, that cool idea. So write them down, and I challenge my students with this. How would you redesign it? What would you do? And lo and behold, here's what we come up with. By the way, we're talking about building cool stuff to functional. I have a student that's, I've known him since he's a little kid. Logan Butler, I've known him since he was a scrawny little thing. Well, he's like 6'5", 290 now, and he gets over the top of me when we're doing demos, and he blots out the sunlight. I can't see anything, so I had to make myself a little layout thing, and I just sheet metal and junk, you know. Anyway, here's what we come up with. Where I need this bucket divider, this organizer to fit, is like right at 9 1/4 inches, I believe. Check this out. A piece of 4-inch pipe measures 4 1/2, right? A piece of 2-inch pipe measures 2 3/8. Wow. 2 3/8 times 2 plus 4 1/2 is how much? Exactly what we want, okay? So, and I have my plate that I work off of. I have it kind of divided up. I don't have to, but I've got center lines drawn in here, and I've done some other things with it, but I go across there, I go across there. Ooh, I'm off. Anyway, I situate things here, and we can center stuff up. I can just look at it. It's going to come out anyway. But we can just touch all these together. Kind of center stuff up visually. Again, doesn't have to be exact. So I'm going to fire up this bad boy 285 here. I need to, this is one thing that really gets to me. You turn a cylinder on, turn it on real slow. It's got a flow meter. Turn any of them on slow, and then turn them on full. High pressure cylinders turn on full. Oh, I've got the wrong one. I've got the wrong one. Oh, God. This would be a good operation here for anything that we've been talking about. Brazing, you could silver solder, you could TIG silicon bronze, MIG, you could even stick weld these. But really all we're going to do is tack them together. What are we reading here for volts? Got 035 wire. 18.7's a little hot. Let's go down here to 17.2. Let's get down here about I'm going to go down here to 165. An educated guess. Again, we are just tacking these together. They do not need to be welded fully. Do not need to be welded fully. Get this guy out of here. here in just a second. I'll tell you what we like to do. Hand me a piece of junk right there next to you. No, just piece of plate. Yeah, piece of plate's fine. Mr. Johnson alluded to the fact that you don't see a professional welder just walk up and throw down. He always tests his equipment here. You gotta make sure my gas is on every time I do this. Now, I wonder how I got that right on the money. 17.2 and 1/6 something. I need to empty this out here. No. The first thing I did was, when I started this project, was build myself a different handle, and I've seen some really cool ones with a braided rope, and that makes sense too, because if you're going to take it up high and you want to tie it off. But I made a long oval here because I like to put a can of rod in the center as well. Silver soldered some old time fine cut consumables on here, the junk, but about 9 1/4 as this tapers down. So the first part of it sets down in there, and there you go. I want to build another section of it. I'll sister this. I'll do another one right on top of it, except when I do that, I am going to I'm going to have to cut or shave into these. I could use, let's see here, 2 3/8. I could probably go out to the stockpile here and grab a tubing. Actually, I'm looking at some right now underneath the table over there. It's a smaller diameter tube. Or I could cut parts of these off. But what I'm going to do is make them stack on top of the other one here. But this bucket being tapered, I want to make another one that fits about 4 inches below this one here, so that things will stay in there, the rods will stay more upright. But the first time I built this, the one that I pulled out of there a while ago, a place for my chipping hammer on the outside, which is kind of quick draw type thing. You always got to pull it out and twirl it around your finger, and it's good on the job site. You do that. Chippy slag, got room for your wire brush, wedges, a couple of fit up tools if you need them. You know, this was all about the fans and something to help them out. Nothing for me to make a gazillion dollars on, but now that I'm thinking about it, send me some money. Anyway, you get the idea. We can kind of build these rings, and you can shave them down. You can modify them. You know, your hammer, your 2-hole pins. I mean, you can make a separate bucket, a whole separate bucket for your fitter if you like them. I like my standby guy, so I'd take care of him in that respect. Another thing that I have gotten into as far as repairs and cool tools. Repairs and cool tools. I was inspired by one young Dabs Wellington here recently. He had a cool tool that a couple of bearings, and I couldn't find the wide ones. Hand me that piece of copper tube there, young man, and then hand me a dirty one. A little rough on the grind there, but so natural color old copper tube. We pulled this out. It was part of our purging into each booth argon lines in here, and I got rid of it because it was a waste. Anyway, the natural patina and the oxide on the copper tube, we clean that off on a belt sander. You walk up there and put this up to the belt sander, and it will spin according to, I mean, you'll feed it through there at the speed. It's kind of a pressure thing right here with your opposite hand, but it'll clean that off there in a heartbeat. I've done it with aluminum. I've done it with some large steel pipe that we're getting ready to TIG weld on. It just does a great job. Probably not even OSHA approved, and I modified mine a little bit. I put it ergonomic bend in it there, or a set, and another TIG silicon bronze job. I'm just kind of ate up with that stuff. It's so simple, so fast, so clean. And as are two visual aids there. We got any questions coming in that I need to address specifically of stuff? Had a repair up in the auditorium the other day with a maintenance guy. We had the auditorium been up there 1925 or something. It's really old, but they had the cages down below the bleachers, and they've been playing dodgeball up there and getting rough, and a lot of the expanded metal was broken away from the cage, so we came in here and bent a piece so that we could pull that stuff back to us, tack it in there. Pulled one of the Rebel machines up there and ran off 110 volt and with gasless flux core wire, and got it done in a hurry. So, all kinds of little different applications. I believe here's something that I was doing one time over the winter time. I did a cross, and then I was going to do some other items here, but I made myself kind of a jig for symmetry. Got in doing a little horseshoe work and pushing nails around. That's a little. For symmetry, I did a center punch line down through here where I can still move this around. It's still loose. Actually, I'm building these upside down. And by putting the nails on here, they set in far enough that they're recessed still, but I can put a spot of silicon bronze on here. It doesn't melt anything, it doesn't show up. And then one step further, I think the cross I had put gold paint down in the trough for contrast of colors and stuff. And somebody said something about cool play on the brass, or polishing the brass inside the nail trough. Well, that's not what I did. I cheated and put gold paint in there. But then, hey, you mentioned it, so I'm going to try it. And I did. I came back in here and I did put, this is actually aluminum bronze that I put in here. Aluminum bronze alternating current on steel. I'm sure that sounds kind of strange, but that's what works well. And I polished it back. I still need to get some more polishing, needs some more work done. Building this for one of my supporters out west. I kind of butchered this cross down in here. Didn't get it to quite go right, so I'm going to rebuild it, redo it. Like Garrett said, he'll go in and shoot a video and do something wrong. Stuff happens out here in the shop all the time. I am forever correcting my mistakes, and it's just one of those things. We all we all make mistakes. I know I do, and I don't try to cover them up. You know, they happen. Most of the time I try to laugh about it, but some of them just aren't funny, you know. Anyway, you know, the impression is build stuff that's functional, that's cool. Next time around I want to do, I've had a lot of people, I don't know how much time we have left. We're at 1 o'clock. I could go all day long. I don't know who wants to do that, but I beveled that piece of pipe over there a while ago. I said I was going to get to a fit. I could. If anybody wants me to keep going, do this fit real quick on a uphill, downhill on the Renegade. Yay, nay. John Minch want to challenge me to a route here on the Renegade.
No one's replied yet.
Huh?
No one's replied yet.
Nobody's replied. Put them all to sleep, huh? Hey, did anybody ever answer my questions about brazing and silver soldering and those temperatures? Anybody ever get to those?
Josh Prieston said, yes, please.
Who?
Everybody's saying, let's go.
I want answers to that brazing silver solder thing. What were they? Were there any good numbers in there? I want the magic numbers. No?
One said 300 to 350 for silver.
Oh, no, that's too cold. Anybody else?
No, that was the only one. Some Larry Bowmore said 6,300 degrees.
No. 5,300.
Said, what was the question again?
Okay, the question was, brazing happens at what temperature and silver soldering happens at what temperature? I mean, the definition of that.
840.
That's the number. Who's that? John Minch, probably.
Kurt Carlson.
Who?
Kurt Carlson.
You the man. That's what I'm talking about. Yeah. Brazing 840 and above, but not to the parent, or not to melting the parent metal. Silver soldering, or soldering I should say, 840 and below. Now, one more question on top of that. The bonus round. The bonus round. How does that happen? How does the bond physically happen? What term do we use there? Come on. You got an extension cord there, old bud. Anybody?
Fusing?
Who?
Fusing.
Yeah, how does the bond work? What's happening in brazing and stuff? How does brazing work?
It's in wetting.
It wets. Huh?
At adhesive bonding.
Is what?
Victor Rose said at adhesive bonding.
Adhesive bonding?
Yeah.
I could put super glue on it and it'd do that. Come on. Gotta have.
Saying fused.
Huh?
Everybody's saying fused.
What's that acronym? Let me Google that for you. If I give the answer, they're all going to go, oh, I knew that. How about capillary action?
back on.
How about that?
Everybody's saying you got sound now.
Huh?
You got sound now.
Gee whiz. I mean, I don't know. It's just an item that I've found them numerous times over the years. I mean, they make all kinds of stones like this. And I found this one down at the Weld Supply store, just sitting back, resting comfortably. And I know it hadn't been used in a long time, so I'm wanting to buy it. What do you do with my spacing tool? Well, let me go grab a spacer real quick. Let me go grab the Sam Hackman spacing device. Some people will run a piece of 332 wire and bend it, and I don't care for that myself. Here's our piece of silver solder a while ago. I was going to go grab a hacksaw blade. I do believe there's one on the table, but this is roughly 32nd. I just eyeball them anyway. I mean, gee whiz. But to me, everybody's got a fit. They always like their personal preference, of which you never get in the field. But
Someone asked, why is the pipe bevel at 37 degrees?
37 and a half plus or minus? Well, I don't know. That's a good question. It's just always kind of been that way. Ask that same question. I'm going to ask that question in return. How come structural is 30 degrees? You know? How come structural is 30 degrees? Piping has always been 37 and a half plus or minus. I mean, it depends on the alloy, obviously. And there's all kinds of joint configurations, and there's compound like J bevels, and you can get into some weird stuff for the joint configurations. Uphill, downhill, it doesn't matter to me, because they make this thing called an amperage knob over here, the adjustment, which I need to get this little guy up and going. I haven't seen this little guy in a long time. You want to zoom over here, sir? Oh crap, he's not even plugged in. Oh. Hello there, young man. How have you been? This little guy, gee whiz. I mean, I've always been impressed with this guy here. 35, 40 pounds. You plug this in or wire it into three-phase, it is 300 amps. Okay? Single phase is 200 amps, but on that 200 amps, I ran a piece of 530? It's 3/16 70/24. Big old tanking rod. And that, I mean, I had to turn it down. I thought, 200 amps would handle it. I really had to turn it down. It's a hog of a rod, and I mean, it put it in there pretty nice. I want to go here at about 78 amps. I want to go over here to soft and crisp, and I want to run that up to, since I'm on the 60-10 side of this, I want to run that up to about 40%. I'm happy with it there, I do believe. And we'll get out of that and we'll go back to our 78. Okay, I need to go grab a piece of E6010. I want to make sure I have a ground. I've been trying to weld without a ground for a long time. Let me grab a couple of rods here. 1/8 inch 6010. ESAB, sure weld, 10 plus. What did he call me?
What model is the small machine?
Like I can even hear you. Do what, dog?
Someone asked, what model is that small machine?
ESAB. What kind of program do you think we got going on here today, Matt? What model? Well, it's a ESAB ES300i. Been out for a while. Dandy little item, I think. Solid character. Hello there, Sentinel. How are you doing today? It's the little things in life that inspire me. Here's what turns me on, a little ergonomically correct electrode holder. Ay, 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 ay. See that little gap right there? I have about the thickness of a dime on my root face or my landing, whatever you want to call it. I have about the thickness of a nickel for a root opening or a gap, whatever you want to call it. My first tack is just to fit them together. And no more, because I want to turn this 180 degrees, and my next tack I want to do just the same, just to fit them together. And here's why. And I do the same thing in the field. I understand that I'm right here on the table, but I can do it on jack stands. I want to equal out this gap. Right now, I'm real wide over here, and I'm real narrow over here, okay? That's cool, because that's the demonstration that I want to do, is fit this together and have to move this over here. It's a pivot. If I put too big of a tack right here opposite my first one, or if I would have put too big of one to begin with, I've got a little bit of high-low over here close to my first tack. Everything else is good. But even with that, if I needed to, I could still move this back and forth and pivot these. You're not always able to reach in like I'm doing. You have to judge it from the outside. So I've always used a series of wedges. I purchased these. I've had students make them for me, but these go down to almost nothing. And you can beat the daylights out of them and they don't bend and mess up. So, you know, I can hold this open, but I can get the fit that I want in the field with full length pipes or here in the shop. Basically the same thing. Go for tack number 2. Come on. Come on, darling. Come on. All right. Now, what'd you do with my hammer? Hand me that hammer over there, Reed. I am like very tight over here on this side. I am too loose over here on this side. I want to equal that gap out just a bit. So I'm using these 2 tacks and I'm pivoting off of that. A little bit longer of a tack there. Been running those downhill tacks. I'll run this one uphill. Been trying to be a good boy here and not get arc mark anywhere. Lest the inspector Garrett would come back down here and bust me for that. Oh, grind that off. All right. From here, uphill, downhill, to me, I just make adjustments on the machine. Really, I can give myself the same fit. I do have a favorite downhill fit that is it's pretty tight, and I like to run hot, stick it in there, stab it in there to the point where I'm actually bending the rod. I'll demonstrate that here in just a second. Right now, I want to do, this one's fairly tight, and I want to do it uphill. No, I don't either. I want to do this one here uphill. So what I'm going to do is plug in another grinder and feather these out a little bit, grind them thin so I can blend into them. Hey, come on, pay attention here. You got me cord lock, son. I mean cord lock. I didn't know the camera operator was supposed to be on his own camera. Is that right? Oh, you checking on your boy? You checking on Dez? How's Dez doing? All right. Well, 2 quick routes, uphill, downhill, and we'll call it a go. We'll call it a wrap. By the way, folks, I still need to answer questions on that first go there in my week. I'm sorry, but I butchered that thing. My camera guy was supposed to be paying attention to the audio. Yeah, where were you on that one? I think we butchered that. So I'm going to feather these lightly with a cutoff wheel. All right, I believe we said we were going to do the uphill first. We'll do a little section right here. I'm going to go my downhill section, I want that real snug one. I'm going to do this one here because it has a little bit of a wave to it, and that's something that I want to get into. We talk about stitch. Some people call it whip incorrectly. I don't want to get a whole lot of the arc here, but a stitch to me is a movement where you step out of the weld pool. I do it. It'll happen both ways. You do it correctly, you can stitch out of a weld pool if it's starting to get away from you, and you can make it freeze. You can also stitch to make a keyhole open up. It takes a little bit of a long arc to do that. In any event, these techniques, always want to hold and maintain some kind of an arc where you're paying attention to the weld pool. And by the way, Weld Pool, those of you that have run ESAB 7018 Prime, I know you're smiling. I ran that rod for the first time, when was it? Early last year, I think it was. Holy smokes, whoever made that, you need a raise, man. That stuff is like so nice to run. It's butter smooth, it goes in, sticks where you want to put it, and then it stays there. So I'm running 78, I'm at an 81. Who adjusted that there, by golly? I'm gonna go 75 because I'm going uphill. I'm on 60-10, I have 40% in the dig part of it. Let's go, I can actually go down a little bit and go 72. Some people just flip out on where we run amperages at times. Again, it's all about your preferences settings. Please don't come on and tell me that I have to run someplace or I have to run a certain amperage to get someplace. I've passed way too many x-rays over the years to, don't tell me I have to run my root at 87 or something. I'm gonna laugh at you. You're gonna have to buy me dinner. Anyway, I may stitch this in here, but my attempt is to get 100% penetration.
You want me to zoom?
What?
Zoom in?
No, well, you can, but I don't want you to get a bunch of flashing arc, but. Wow, that ran in pretty nice. Good to see you there, old buddy. Been a while. Glad you got off the shelf for today's presentation. Gee whiz. I think that inspector guy'd probably take that profile, okay. You gotta knock the scalies off of it there. Oh, it's nice, it's okay. Now, well, I'm too tight right here. Got a tack here I could blow through. Let's have a little fun. I want to feather this out. I'm going to feather this tack back again, and I'm going to turn the machine up. Didn't I have an 1/8 inch blade around here somewhere? I got all these grinders and I don't have a abrasive. That's all right, I'll use this again. One more little touch here. I see all kinds of subtleties in all kinds of situations in the shop. As Ian was talking about, you know, you get into these fit configurations and their tubings and repairs, thick metal, thin metal. It's machine adjustments, and a lot of the subtle things matter. If you were paying attention, you'll see me kind of angling this back and forth as I'm feathering this out or thinning it down. And that's because I don't want to just shove a cutoff wheel right straight through here. If I did that, if I started out with the thickness of a nickel, or let's just call it 332, if I had that for a root face and I was sticking a grinder in here and I just shoved it right through, and then all of a sudden I've got a real thick root face. Well, it kind of makes it hard to get the penetration profile that we want. So I recognize this fit here. I think that I can get a little frisky with the settings here and go up in numbers. I'm at 72, I'll go to 85. I'm gonna drop this down just a little bit. I'm gonna go from 40 down to 30. And I'm at 85 amps. And holding a real short arc, I should be able to cram this in here pretty good. Let it burn, but you may see this rod flex just a little bit. So I did part of it uphill. Now I'm doing this downhill. Learn them all, you know, horizontal. It's recognizing situations here. Got to know what you can get away with if you're going to pass X-ray. Let us pray. Oh! I almost made a classic there. All right, here we go. Oh no, come on. Huh. Well, you laying down on me here, old buddy. I better go to, instead of 30, I'm gonna go to 65. And if you lay down on me one more time, I'm gonna go to 90 amp, 95. I need a cup of coffee over here is what I need. You know? Nah, come on. And that's cool anyway because I ran into that tack. Again, blowing in there, root profile. The walls are broken down, we're good. We come back in here, we clean that up with a hot pass. Finish it out downhill, part of it downhill, finish it up uphill, doesn't matter. It's all about your rods, your settings. We'll go E6010, 7010 on the roots. You know, uphill, downhill procedures are different a little bit. One of the rods, and I had a gentleman from ESAB in Pennsylvania send me some of the 8045. Thank you, sir. I really appreciate that because we've been doing experiments with these different brands. And the 8045 P2, I believe it is, P2, downhill, low hydrogen rod, good running stuff. High-speed deposition, really good for doing sleeves and API work out in the field. People are getting away from the cellulose rods on some of these high pressure pipelines. I believe in my first session I missed the opportunity to pull out an item right over there on that back side of that machine over there. I'm by my toolbox is a number 5 gun, other side, back side. Is there a number 5 gun back there? Number 6 gun, big gun. Oh, God, that hurts. Yeah? Yeah, I don't know if anybody's... I'm an old timer, and I've been around some of this stuff since way back. And by the way, Tweco used to be in Wichita, Kansas, right up the road. This is a brand new number 6 Tweco. How'd you like to weld with that all day long? Oh, yeah. That's a hog right there. And here it is compared to the Spraymaster gun on a 285, which we all know this thing will hump. I mean, I've had this thing cranked up on some big wire and some hot welds. Look at the size difference in these two. Good Lord. Pretty impressive piece of equipment.
Okay, you're back on.
What?
You're back on.
Okay. Well, real quickly, I just want to end this by saying this. We talked about oxyacetylene welding earlier. Here's 2 examples of old-time oxyacetylene welding. And when I say old-time, these were in service up until about a year and a half ago. 900 pounds of gas pressure. And, I mean, you can look at this. It doesn't have a root in it. It's all rusted, pockmarked stuff. So as far as infrastructure, we got stuff in service that's has been welded back in the old days with oxyacetylene. Great big ginormous weld. This one's really interesting. I mean, I understand the Europeans still do oxyacetylene on certain size pipes up to about 3 inch or so. I want to get back into doing some of those demonstrations myself. I hope this has been educational and informing. Didn't really cut up that bad. Tried to be a little humorous. I laugh at my shoulder hurting, I guess. I don't know. If you have questions, follow up. I still need to follow up on the first video. Ian will be back on next week, or maybe we're going to tag team next week. If that's the case, then I need to pull out my my Ian John. I got to get my hair spiked up and stuff, so I got to get ready for that. Anyway, we certainly appreciate your questions. Good luck. Who won did they announce the winner yet? Okay, well, I'm envious because I'd like to weld with one of those Savage hoods. If somebody bring one in here, and whoever the winner is, you're more than welcome to come in here and we'll throw down a little bit, finish up this pipe weld. Thanks so much for watching. Stay tuned for next week for National Welding Month and Weld-On, sponsored by ESAB. Thank you, folks.